Hello?
Hey Bradley, how are you?
All right, how are you?
Okay. I sound worse than I am, but I'm a little bit under the weather, so I probably won't talk that much today, which may be a relief to some. But I'll probably have limited things to say today.
Okay. Well, I don't know if anyone else is going to show up. I know that a couple of people. There's Samantha. Hello. I know that Morgan was camping and a couple of people couldn't make it, so.
Yeah, Brian won't be able to make it. Morgan an hour ago said he was coming to a cafe, but I don't know.
Yeah.
It's gonna be a long time to wait for us. So
Yeah. That might be kind of spotty, though.
yeah.
Well, anyways, welcome to the meeting.
Nice, yeah.
Yeah. Uh,
Hi, Chris. How are you?
how are you?
Okay. I'm a little under the weather today, but it's okay.
Yeah. So, I don't know. You want to get started with updates, or Samantha? Do you have an update for us?
I don't have like a huge update. I've been sitting and reading and writing a bit more with my research, and I've been like last week I mentioned the robotics summer job I have, and it's more of like a teaching robotics summer job where you teach like the next generation of like STEM students how to like look at different codes. It's like drop down codes at first, and then you move to like a little bit of simpler like codes, like the hello world code and like things like that teach them more. And using, I don't know if you know what a Sphero robot is, but it's something like it's like a little ball and they like drive it around and code it themselves. So like those are like lessons I've been preparing this week. But that's like my update. It's very crazy.
That's great.
Yeah, I think that's really cool. Anytime you want to give us updates about that, you're welcome to do so. And that sounds like, have you done it before, or is this your first time with that?
I've been doing this program. I've been like counseling with this program since I was like 11, and the last 3 summers I haven't had the chance to 2 summers because of COVID. So now we're finally going back for like a small time, but hopefully she extends it a little bit more. But it should be fun.
Oh, that's awesome. I mean, I think that's great. So.
Yeah.
Yeah, I don't know if I think Amanda's traveling. I think Brian has something come up. I think Morgan's also traveling.
Yeah.
So you may finally get to go through all the papers you want to go through today. But as far as my update goes, I mean, I think you pretty much know most of the things, but Bradley. But in a general sense, this week hasn't been moving the ball forward as much as I wanted it to. Had a few things come up and some other, I got a little bit under the weather, so that's fine. But cognition future stuff is going fine. We had our chapter 4 meeting this week. We'll do chapter 5 next week. I'm happy that that's trucking along. Google Summer Code stuff, I'm sure I'll say more about later. But it's an interesting batch of people. I think there will be some. I'm really curious. I'm very happy to be a part of it, and I think it'll be a really interesting, 3-pronged approach to our project here. I'm happy to. I really look forward to being more involved with that. And I don't know, like, when is the like? We're in the community period now, right?
Yeah, so the next few weeks is the community period, and I usually try to do, like, I try to be a little bit broader in terms of what people are exposed to. So, during the coding period, we try to be very focused on the project, but like in the community period, you can talk about a lot of other things. And in this case, we'll be probably talking about a lot of things related to data and simulation during the coding period, but I wanted to give people like a background in open source software, for example, which is something I talked about yesterday.
Yes.
Yeah.
Okay. And then when does the coding period start? Is it like
I think
July, or is that before? Is that
a little bit before July, but I think I think the community period's like 4 weeks this year
okay?
instead
Okay.
of two. But
'Cause, yeah, it'll be interesting. I will be traveling for work on the 9th, and then at the end of the month, I will be traveling to Chicago. So I think the 26th is still our target date. Unfortunately, I think Jenny won't be able to make that because of when her flight had a different. Her flight has a much longer layover than anticipated,
yeah,
so she may not be able to get in town in time for that. But I mean, even if it's just you and Avery, I'm fine with that too. Amanda said she would be interested in in coming down,
okay,
and
yeah,
also I think Hussein showed some interest in coming down, so he'll be in Indiana. So I don't know,
okay,
but who knows? We'll see who shows up. But I look forward to that.
yeah, that'd be great.
Um, we met with Daniela too, um, and I wasn't. I don't know. I got most of that. I was kind of partially there, but it's good to hear from her. And uh, I don't know. Do you want to say anything about that?
Well,
What, yeah.
yeah. So we talked about some things that she might be doing, and one of the things is to I don't know about resurrect, but create this neuromatch slow pod, where it's actually neuromatch slow pod plus, because we talked about bringing in maybe like unpacking the neuromatch course and then adding in things like resources from the uh, uh, active inference lab. They have a lot of tutorials, and there are other
So
tutorials online that kind of feed into it.
yeah, I was curious because I couldn't tell, and I think I missed either the start of the meeting or whatever. But I know there's a few things that she mentioned being interested in, and like frontier maps and all this stuff was great. But was Daniela like very interested in the Neuromat stuff, or was it more like that was a potential spot that she like got excited about? I didn't quite understand. Like I don't know how to phrase this, but like was she? Do you think she was very much like wanted to pursue Neuromatch stuff, or just that was an option that seems like exciting?
Well, I think she's interested in engaging with it more. I didn't, we actually set up a Discord server to start building something on this, but I don't know. We'll have to talk about it more. It's like,
Yeah, yeah.
yeah, digging into the materials and seeing what's possible.
It's always as like lab manager sidebar. It's always like interesting because there's sort of a certain like the phase between something being an idea and something cool and fun, and then something being born into the world, and then it's kind of an old. I was thinking about this. This is another tangent, but like it's kind of people don't say it anymore. But oh, it's gonna have legs or it's gonna grow legs, meaning like it's gonna be able to move and walk on its own and do something.
Yeah.
I don't hear that anymore ever. I don't hear that at all anymore. So I don't know. I know it's like generational, but the point I was saying is like getting to that phase of like idea to things going is always it's always such a tricky, special, magical, difficult period. So I'm happy to help out with that how I can, and I hope it goes well. But, yeah.
Yeah. I'm going to go over that a little bit in the
Okay,
meeting
great.
here, but
Yeah.
yeah.
That sounded really bad. I'm actually okay. I think I'm on the outside of a like sore throat thing.
Oh,
But the last thing I'll say is Cognition Futures is moving forward. I am on the table is that methodologies paper or methodologies, I don't know, review, whatever it will be. But that's something, and then also Frontier Map, I still want that to go forward as well. And I didn't have time to do it this week, but last week I spoke with Jenny and Plot Twisters and Avery too, but mostly Jenny specifically about the Wii Robot stuff and Plot Twisters' involvement with that. And I have yet to fully write up. I'm basically going to map out the project and say, here's what people can do in it. Yeah, I'm calling it kind of a call for involvement, but I want to maybe tailor something specifically for the lab here, and then also something tailored, like a specific call for Plot Twisters too, so that way they can see what's going on. But it's also, there's a lot more urgent things happening both here and there, so it's not the biggest deal. But I do want to kind of continue momentum on that. I don't want that ball to hit the drop.
Right.
Oh, it's far away. So that's my update about things I want to be doing and am doing, but not a whole lot to show yet in a concrete sense.
Right. Well, that's great. We should talk about maybe today we can sketch out a little bit about what that should look like, or, we can see, where this goes, but, So, okay, yeah. If other people join the meeting, they can join in, and we'll ask them about their updates. So, but for now, I'm gonna go to some other things.
What's your update, Bradley?
Oh, well, I've been working on this stuff here. I've had a couple meetings on different things. Things seem to be kind of moving forward. Like I'm getting a lot more sort of little meetings, and we're getting a lot more of these like initiatives going, and GSOC has been kind of challenging because we have it's like just getting it off the ground.
There's two Diva Worm projects too, and you're trying to wrangle all that together, right?
Yeah, the Diva Worm projects, but those are like, I think we've been working on one long term, so that's not a problem. Okay. The other one is a bit more challenging. That's the graph neural networks. So that's something we'll be working on coming up. So I know you're mentor on that as well. So, it's just a matter of, we do the Monday meetings and then we do things in Slack. Yeah. And I hope during the coding period we can do more of like sort of synchronous, asynchronous type stuff where we're doing demos in Slack. We'll be doing demos in the meetings, and those meetings are recorded, so you can catch up on those if you're not in the meeting. But then, we'll have like things in Slack, or, we'll try to make things, we'll be running it out of GitHub, like I showed yesterday. Every contributor will have a GitHub repository I want them to push to. So.
Yeah. Okay. And I should be able to, I'll be at, I wanted to go this week, but I couldn't make this Monday, but I'll be there. Yeah. At most of the other Monday meetings, so that'll be good.
Yeah, we get a lot of, it's like this meeting, we get a lot of people come in and out, and like, or, during like a part of the meeting, or they kind of come in every once in a while. It's fine, it's like, so, so that's going to work out. And so, but I'm going to move. Oh, and I wanted to mention that Danielle also expressed interest in the frontier maps. So she's wanting to do something with frontier maps. Wasn't clear what I told her to get in touch with you about it though.
Yes.
Okay. So let me move on to sharing my screen here. So the first thing I wanted to discuss was, why don't we go over the submissions first? We always leave that till later. And this again is like, submissions for different conferences and venues that we're participating in. So we have a number of things that are outstanding here. The Wii Robot, which is this, we have these two submissions we just mentioned. the shared cognitive interfaces, which I assume is the orthogonal lab, for the thing that the orthogonal lab is going to focus on. And then the narrative focused one and plot twisters, that's going to be the plot twisters one. And so those are outstanding, and we need to kind of put something together for that. And it's one of those large collaborative things that people can contribute to if you want. If we have to kind of, the way I've found this to be useful, or the way I've found it to be best, is to have one person take the lead and, maybe kind of talk with people and then synthesize those conversations into a draft. And it could be a paper, it could be abstract, or it could be a presentation. But it's better to do it that way than to have everyone say, and I've had this happen before, say, I want you to prepare a certain number of slides or a certain amount of text by this date. And it's like people will struggle to get that together. I know we've done this with Celebration of Women in Computing. And the way that was structured, we all had our own presentation. So that worked out to some extent. I mean, we had some hiccups, but usually, though, if you're doing like a single presentation or paper, my advice is not to just delegate so much. Someone has to take the lead and prepare that, and then get feedback on what was prepared. I know that's a lot of work for one person, but it does tend to get you to the deadline. And I just say that because I've had a lot of cases where it just doesn't work, where you delegate authority and then no one does it because everyone's busy. So yeah, that's for We Robot. Now, we can come back to this. Maybe we can sketch out a little bit of what that looks like. But I did want to mention a couple other things in here. One is the Diva Worm, or actually this is for NetSci 2022. And I don't have the website up right now for NetSci, but NetSci is a network science conference. It's like the top conference in network science. Last year they had a combined meeting with NetSci and what they call the Sunbelt Conference. The Sunbelt Conference is a social networks conference. It's something that they founded just for social networks like decades ago. And NetSci is more of a networks conference for like the theory of networks, and there's a lot of different types of applied networks. But this year they're not doing the combined meeting, but last year they did, and it was a lot of fun. This year they're just doing the NetSci meeting, which I've attended many times. And so we got a paper from DivaWorm accepted into that. So that's going to be in the main session. But also there are opportunities for satellite sessions, or what they call satellites. And I put in the Slack, I put a couple of satellite sessions. So I'm trying to remember where I think they were in this networks channel. So there's a network science channel in the Slack. And we actually have two that I'm eyeing for different submissions. One is Women in Network Science, and I tagged a bunch of people in the lab on this. This is a call for participation for women in network science. So if you're a woman and you are interested in networks, this is an opportunity to submit an abstract, I believe, for a flash talk, so a short talk that you can give on a topic, and they encourage participation in that. So if that's something you're interested in, this is a very strong satellite. This is like a perennial satellite. It happens every year. It's very well organized and run. So, that's something to check out if you're interested. It's in the Slack. You can join this channel, or, join in and say, I want to, I'm interested in doing this. And I can help you with some of the concepts and some of writing up abstract and things like that. Knowing the field in the conference, I can, help you get passionate into something that they will, really like. But that's the Women in Network Science. Then there's also, and I haven't gotten any information about this, there's a network neuroscience satellite that happens every year as well. And that's something that I think they may be accepting submissions for like flash talks again. They're very short talks. And so that's another opportunity. And then there's this other one, I think it's called Net MedSci or something like that. And it's for medical research and medical science. And that's something I might submit a satellite session to on. I'm not really sure what the topic's going to be yet, but that submission is due in about 10 days. So these are, short sort of windows, about 10-day windows where you might want to participate. So when we get some, interest in it, we'll talk more about it in the Slack. So that's NetSci. That's coming up in the actual sessions are like in July, from mid to late July. So that's not too far off. But this is a nice conference. If you can attend the registration, it's virtual and the registration is somewhat affordable. It's, I think, $50 for students. So that's not too bad. It's a full conference, like I said. So that's NetSci. And then we had this CogSci 2022. We had this discussion group. We heard anything back about the discussion group, Jesse? Okay. So this is Jesse had some things in the chat. Okay. That's interesting because the Sunbelt Conferences used to be a college athletics conference. So the Sunbelt Conference, actually, it's a funny story about that. It's that they started the conference and they started having it in cities in the Sunbelt, like in Florida and Arizona, Sunbelt of the United States. It's like the area, like along the southern and western edge of the country, So they'd have, and the point was they'd have it in February, and they just wanted to attract people from the north who wanted to have some sun and some, not be in the winter cold during that time. And so that's how they attracted people to the conference originally. So it's kind of, it is kind of related to this. Then I think Erin also mentioned the Women in Network Science Conference and the Ethics Channel. Yes, I think she reposted that. So I'm going to reach out to Erin maybe about that and see what she has, if she has any ideas about that. I think that would be another good opportunity for Erin to present. And again, we'll have other people as well, try to recruit some other people. On the hearing back from CogSci, right, for the discussion group. So that's so we'll see where that goes. I don't know if that, as I recall last year, it was a little late that we got the notification. So I guess we have to be prepared to put something together quickly on that, if it happens. This INCF conference, this is the neuroinformatics core. These are the people who sponsor GSOC or Google Summer Code. I've submitted a presentation, and this is actually orthogonal lab centric. So this is an introduction of developmental embodied neurosimulation. I think we did this. This is basically the thing that was done at Maine conference in 2021. So back in December, I did a 2-minute talk on this. It was from a lot of our work in developmental AI and some of these other areas. And it'll probably be a little bit more, it'll be not a poster, but kind of a talk. So, that'll be an interesting, maybe I'll be asking for people to contribute a little bit there as well. Then we have these outstanding things like dual inheritance for developmental agents. This is, again, this idea of using cultural evolution and genetic evolution to sort of look at agents in terms of their behavior and their innate properties. That's still in the works. This mentors conference is next weekend. So this is something that I mentioned. It's actually next Friday. So we mentioned this yesterday at the meeting, and I had forgotten momentarily that I was going to be attending this. So, but this is next Friday, and basically they asked me to talk about some of the things that we've been doing with respect to Google Summer Code. So, I've been working as a mentor on Google Summer Code for about 6 years. And I've had a lot of experience at different types of projects. And so I have a lot to sort of give things to impart to people. So that's going to happen next Friday. I've already recorded the talk, and it's just kind of like a matter of, I think answering questions at the session. So we may have to reschedule our GSOC meeting for next Friday. I don't know what time we'll have to be occupied there, but so anyways, that's happened. And so this methodologies in CogSci for EI 2023. This has been on our calendar. It's kind of sitting here. We made a long-term commitment to this. I would say that, like, for something like this where we make a long-term commitment, and this holds true for a lot of these other things that are kind of on the list, maybe we should kind of think about them. It's easy to put something on the calendar and forget about it. And then when the deadline comes, you don't have anything. So, when you put something down, try to make it like kind of partition a little bit of your time every so often to come back and revisit it. Like say, how am I making progress on this? What is this? Because this, we're talking about VR in the meetings, which is great, but we need to kind of have I don't know, I guess we can sit down when the time comes and bring some notes together, but it's also good if we have like maybe something written up that's, just kind of write something up and then put it away and then come back to it later and see if it's still the way you think about it. Because the way this works is, your mind changes as you learn things. And, you can change your mind on these things before they're submitted anywhere pretty easily, right? You just kind of edit it and modify it. But to really kind of have a good shot at this, to make an impression, you need to have to start out with something, whether it just be it could be some notes, but it may be more like an abstract that, you can just kind of go back and revisit and say, oh yeah, that thing. Well, I don't really think that anymore. This has changed. So, it just keeps the momentum going, I guess. This ABM hub, I don't think that ever happened. That was something that we were invited to do, but it's well after the extended deadline. I don't think that happened, though. This layering and folding paper, this was the one that was submitted to Artificial Life. That was then submitted to this BICA conference. Kind of decided at the last minute we should try to do that because, why not? We'll see how that goes. Some of these other things, I don't know. This generative adversarial collaborations, I don't think that's going to happen, but that's, and again, these things, you see them on the list and you can repurpose them for other things, just to have them up in our radar here. These other things, there's a neurosymbolic workshop happening from June 6 to 8, and I know it was mentioned in the Slack. There's also this is the one that we attended, the Systems, Neuroscience, and Evolutionary Theory, and covered that one in the meeting, so that one's been covered. This multi-agent behavior at CVPR, that's something that we missed, so that's going to be read. And then some of these other things are just kind of like stragglers I'm not going to get into. So I think this is, again, I like to revisit this list It's good to do that. So, and what was in the chat? Okay, yeah. So yeah, Jesse said creating some solid ground or document to start with is important. So yes, that's good. So next thing I want to talk about, when we go, I'll review maybe some of the channels in the Slack since we've had a lot of activity in there. And, it's nice to kind of highlight some of these things that we've been doing. Even if it's just links, it's kind of a nice thing to go over just to let people know what's going on. So this Brain Organoids channel has been active. Morgan has been putting things in on different topics. This is, his sort of area more than other people. So if you're not into this, it's fine. It's just that, we have different areas of the lab that people are into. But he's really put together a lot of things in here and, talks and other kinds of things. So if you're interested in brain organoids, even if just casually, look through some of these papers. They're like toolboxes for computational tools. There was a thing that I think I mentioned in here as a little joke. Jesse will appreciate this. Morgan said, great Michael Levin talk today. And I said, which one? There's always a Michael Levin talk going on somewhere. And then the next day, Michael Levin posted this on Twitter about his father taking screenshots of his slides online and using them to make his own talks. So that was something I thought was kind of funny.
Wow, there you go.
Yeah. So this, and then there's some other. So this was the talk: cell intelligence in physiological, morphological spaces. This is goes beyond organoids to talk about what they call biological agency, which is where you think about cells and you think about like computational agents, and we think about computational agents as sort of mimicking intelligence, and so you can think of cells in the same way, but they do things like information processing and they behave collectively. So people are trying to come together with a theory of sort of cell intelligence or this basal intelligence, or basal cognition, as they call it. And so it's something that he's been really selling quite a bit. So this is, of course, relevant to organoids in that the organoids self-organize into patterns and they do all sorts of processing of information. They, convert to different cell states, cell types. So there's a lot of this sort of stuff going on. And it's I think it's a pretty solid explanatory framework, although I think there's probably a lot of pushback that can be made as well. So, these are things you might want to check out. Cognition futures, we've been doing our we've been doing our reading group, and that's been really fun. I'm going to get to this post here that Jesse made, I think last week, later in the meeting. But this is a Jan LeCun Facebook post on some of the recent progress in AI. We'll kind of go into that in a little bit. And then we have our channel for Google Summer of Code, and this is something that, of course, we're interested in open source ethics. And so that means that, how do you create an open source community that's both inclusive and well-behaved and sustainable, and you can do the things that you want to do. And so we've been talking a lot about like collective behavior. We've been talking about other types of topics. Actually, I had a post in here yesterday on how do you moderate spaces online. So this is a sort of a study on, moderating Reddit, and so how people sort of join Reddit, and whether it becomes a toxic discussion or not. And there are ways that you can moderate that, or do a better job of moderating that. And so they can identify toxic behavior, toxic conversations using machine learning, and they can, try different interventions early on in the channel's history, or when people join the channel, and they can change that outcome. So, these are kinds of things that we're kind of interested in with this open source ethics idea. We've got a lot of readings in here. We've done a lot of readings, but the idea is to get to a place where we can do some concrete research. And so this is where we're kind of headed in the community period. I mentioned this in the meeting the other day. This is going to require us to really kind of pin down a couple things that we're going to do in the 12 weeks. And, it's very tempting to be very all over the place with this. And I want the conversation to continue in here. But I also want people to be mindful that we need to be a little bit more focused in terms of the actual outcomes. And so, I don't know if the next channel, we have a data science ML channel. So this is more for data and data science. And so people have been contributing to this channel with different things, talking about GPT-3 and talking about some of these other topics. It's kind of a grab bag of topics, but they're related to data analysis. Ethics, Society, and Tech. Erin's been in that channel doing a number of things. She's been posting on different topics here, from collecting private data to this is one that was about it's a data set on like identifying misogyny, pornography, malignant stereotypes, and sort of understanding how to sort of, I think, how those are reinforced in some forms of content. So this was an interesting, this is a paper by Abeba Burhani and colleagues. And then I think there's this Twitter thread here. I will no longer engage in philosophical discussions about conscious AI, superintelligent machines, and here's why. So this is Hussein, who agreed with this. If he were here, he'd tell us why. And I think the conversation basically boils down to that we're really not at a point where we have to worry about this too much, despite the hype. Because a lot of people argue that we're at the precipice of super intelligent machines taking over the world. But then again, there are other problems in the world that are much more pressing. So, I mean, this is a nice sort of way to pour cold water on some of the hype that happens in some of these spaces. So that's that's what's going on there. And I look through here and I see a lot of really interesting threads, but this is something maybe we need to think more about, like bringing them together at some point. And I'm not sure if it's a matter of like writing up a review, or I think we've tried in the past writing up like different sort of annotated bibliographies on some of this stuff. So, we go through the thread and we find a source and we write up a little bit about, what it is and how it's relevant to other parts of what we're doing. But it's also, the case that you find something you really like, some story, and you start doing research on it. And, it hits on something that's relevant to your work, and you take the ball and move it forward. So I encourage, especially in this Ethics, Society, and Tech channel, to really kind of think about some of these posts and how they really kind of unpacking some of this stuff. So there's an events discussion as well. There's some of these events. We don't really have any new events on that. General, there's not much going on there. I showed you the Network Science channel, which is where we talk about networks and network science. There's a lot of just papers, and again, this Women in Network Science Society, which is a good society if you're a woman and you're interested in networks, but also male allies to support women in network science. And then Neuroscience Networks, which is a different networks channel. It's more about like networks in brain imaging and in connectomes and things like that. So, we're interested in networks in the lab, and I don't know if we haven't made that as clear over the last maybe 6 months as it is, but there are a lot of different things that we're doing in networks, especially with respect to like collective intelligence and some of these other topics. So, yeah. So that's neuroscience networks. Virtual reality is the last one I'll talk about, which is where we talk about virtual reality and neurotech. We have a number of things in here on some of the innovations going on at some of the corporate labs and some of the academic labs. So there's some nice talks in here. This is from the Spatiality conference. This is a different talk by Francis Dolan's Non-Human Primate Spatial Cognition and Virtual Reality. So this is, a very deep topic in virtual reality, this idea of spatial cognition. And so that's one of the key, I think one of the core areas that people have used virtual reality to study is spatial cognition. And the reason it's so popular is because a virtual reality sort of opens up the spatial domain. And you can actually explore that spatial domain without actually moving through it. You can explore it virtually with a cursor or with something else. And that allows you to do things like neuroimaging without having to create specialized equipment to measure the brain as people are walking around. People can walk around a space, that's maybe like a room, and explore a landscape or something like that. But they can also lay in a scanner, for example, and they can explore it with a cursor. With primates, it's hard to get them to do things that are, and then also measure their brain activity that are, sort of organized, naturalistic experiments. So this is another opportunity to study spatial cognition, not only in humans, but across species. So this is talks a little bit about that. And then this is another talk that Morgan posted, Patterns, Memories, and Maps, the Brain Circuitry for Navigating the World. So this is another one on sort of spatial cognition and navigation. And again, this is a topic I think that's it's been very well studied, but there are also things that can be done that are very, innovative. So there's a lot yet to do, and there's a lot that's been done in that area. Another area is in like haptics and motor control and a lot of these other things. And that's an area I've also been interested in the past in doing things with. And, this is something that, it's very much part of this embodiment theme, right? Like it's where you have your body is doing things in the world and there's feedback to your brain and there's this sensory motor loop that happens. But in cognitive science, for example, people just tend to focus on the sensory motor loop as this sort of visual thing where you're coordinating, what you're learning from vision and maybe, what you're doing with your body and then with your brain. And that's usually the extent of it. There are other people who are looking at things like motor control. There are people in therapy, areas of like medical rehabilitation and therapy, where they're actually looking at the motor system as sort of a physiological system. So they're looking at, people trying to rehabilitate their motor control after a stroke. And so they may use things like virtual environments where they have a stimulus like a virtual road, and they'll put the person on a treadmill and they'll have them like walk on a treadmill, but they'll change the incline of the treadmill up and down, or they'll change its speed, and they'll be able to like help people not only regain control of their muscles, but coordinate their muscles with visual stimuli. And this will help them to regain function. So there's a lot of that work that's been done. And so the musculoskeletal system, which is of course your muscles in your limbs and other peripheral nervous system components are also very important in this sort of embodiment in this sensory motor loop aspect. And so this is something that Meta has developed called MyoSuite, an embodied AI platform that unifies neural and motor intelligence. So this is bringing together some of the, well, maybe we'd call it physical intelligence. I think we've called it in the past, where you have you're manipulating an object with your hand, and you're interested in like how your hand, the muscles in your hand, and the what they call muscle synergies, which are where the muscles move together. How those behave when you're manipulating a virtual object versus a real object. And so there are different ways that you can study this. You can use things like EMG, which measures muscle activity. You can use other types of measurements, kinematic measurements, which measure the movement. And that can tell you something about how much effort is being put into something. Sometimes if your finger doesn't move right, you can tell from the EMG measurement or from the kinematics. And so that's important in terms of like how your body is treating that stimulus. And then how sort of psychologically how that's working in the brain, but then there are also these physiological indicators at the periphery of your nervous system that are also important. So that's another area of VR that's being developed. I think the technology again is being developed for this, more and more. It used to be that you had this, sort of a dearth of technology, and it wasn't very good, and it was really expensive. So it was very hard to do any sort of like experimentation. And now that technology is coming out, I think more and more where it's cheaper and people are kind of innovating in the space. You can probably build your own technology fairly cheaply now, and there are a lot of smaller recording systems. So EMG, is something you could probably measure using very compact sensors now, and get a real-time measurement of things in the different muscles in the body. So this is something that is really, I think, moving along, and this is something, that's going to lead to people understanding, I think, more about like how the entire body operates in these embodied worlds, or how you embody yourself in these worlds, I guess. So that's I think all I have to say about that. I had another talk that I watched on YouTube. This is from a research group. This is from the University of Illinois, and they're doing things with extended reality technology in terms of like rendering stimuli and different things, different visual objects, virtual objects. So they have these technologies that are sort of optimizing the presentation of virtual worlds, and they're looking at developing the software and benchmarking the software. So they're using this for different purposes, but it's that's part of the technology too, and that's something that is also being optimized as we speak. So, and then this Allen Act, an open source framework for research and embodied AI. This is something Morgan posted, but again, it's this embodiment. This is the Allen Institute. So the Allen Institute has I think a brain science part and an AI part. And they're doing this. They have this open source framework for sort of embodied AI. I don't know if it's like stimulus presentation or if it's like virtual worlds for robots. So this is a growing collection of embodied environments, tasks, and algorithms that provide reproductions of state-of-the-art models, and they have documentation and tutorials and things like that. So this is so support for some of these robotics environments, habitat, which I think we've mentioned. So this is where you put an agent in an environment and you can train it. Task abstraction algorithms, so you can train it on different algorithms. So this is a nice resource. I think we've talked about doing this sort of, putting our agents in an environment, or kind of using agents in an environment to test different hypotheses. I think this is a nice framework for this. I know we talked about using Habitat, but no one picked up on it. But this might be an easier way to do it, because sometimes you pick up a tool like this and you can't figure out how to use it, and so that's a stumbling block. But I think we should explore this more. So that's all I have to talk about with respect to the Slack channels. I mean, we haven't done anything like that in a while, but I wondered if Jesse or Samantha had any comments about that stuff.
Oh, I'm glad to do that. There was something about Jan LeCun you wanted to mention later, but I don't know if that's something you still want to do.
Oh yeah, I'll do that.
I really want to look at some of the what are they called? The Habitat AI thing and the other one from Allen Institute, and also that thing from like whatever Mid is developing. I think that was one of the things you mentioned too. But like those things are all. I kind of want. I almost want to basically get an intern that I could say, hey, could you keep track of these advances in technology environments and also like implementations, because I think that would be very useful for us to do. On a similar note, it would probably be a good time to put together some, if we want any specific involvement or call for involvements from interns, or asking like the Albany and Casey and stuff to say, hey, we have an opening here. We should probably do that. I haven't been able to do that recently, but that's something I could do this week. And this might be something for me to. I might specifically. It's on my face. I might specifically try to do the one I just mentioned, because I think that would be very useful for us.
Yeah, well, I think with VR, I think definitely it would be useful, because there's a lot of new technology always coming out, and I have another channel and in a Discord that I run that we've been talking about different technologies as well, more like along the lines of AR, but it's just like this plethora of stuff like coming out, like people are always there are all these startups and they're creating different technologies, and there's so much complexity in that space. It's like, do you want to have something that's like a mobile XR, which where objects pop up in your environment, or do you want something that's interactive, or do you want? And so there's just this zoo of like technologies, but then how do you use them? That's no one's talking about that too much. It's just kind of like, here it is, another demo, and then the question is how do you use it? What's it good for? What would it maybe be good for if people had time to really invest in to make something happen? And then what is the sort of the potential for it? Like, are we just looking at like vaporware? Are we looking at something we can really get into?
I feel like there's a lot of and there's some exceptions to this, like cognition that Morgan mentioned, like I think it's called Kura VR or Kura VR, who I kind of loosely know one of the leads on that project, and some other. A lot of things in this space seem to be like, hey, here's my, for lack of a better term, kind of unfair, like my gimmick for how to use, like this feature or this like cool rebranding of existing technology, or like my version of Pokemon Go or whatever, and that's cool, but there are some things that really I think it'd be interesting to look at in terms of both something really, really well hitting a need or a something being really, really well tailored towards a specific need, versus something that is creating a whole new avenue for experience. And I know like something Meta's trying to really go in the novel direction in that sense. But there's something called like Mind VR, which is um, very very well tailored, and I keep missing the opportunity to get um, a demo of this. But Mind VR with a Y, my MYNDVR, I think is like something very tailored towards people with disabilities and very like you basically get to you can have a sort of a easily guided tour with the headset, and then like they go on a vacation or go on the Alps or do some activity that like, a mostly disabled person would be able to do, but you can have um, it's really well tailored towards this very specific thing. And I think those are interesting examples, even if they're not the most innovative in terms of their technology. It's just the implementation and the experience is really well tailored towards a specific thing, or towards a specific audience, but also like a specific, if you will, deficit that they're overcoming with using the VR or AR technology. I know cognition, with the one that Morgan introduced us to, is about people with speech disabilities, and I know that at least as per their public demo a couple months ago, Facebook's really intentionally pushing their augmented reality glasses to be a visual sort of component, like a visual reference aid to their personal assistance work. You know, like trying to make them work together, which is cool. And so I think having someone to really, I think well, we can, but having a sense of what is being done in this space would be valuable, and not just in general, but also like in a maybe more specific or selfish reason. Like I know that maybe what I'm saying actually is the foundation for that first. Sorry, let me adjust this here. Maybe what I'm talking about is literally the foundation and background to the first We Robot paper about cognitive interfaces. I think the other thing I just said fits in that, because that's kind of what I would like that whole first project to be, which for those who don't recall was like the cognitive interfaces one that was more technically focused. If we did like essentially a big lit review of what I just said, I think that would be fine. It's a poster for that. That could be that just fine. But so that's cool. I literally talked myself into furthering that project, so that's cool. But what I was going to say is there were two things that come to my mind after saying all the resources I just mentioned. One of them is that the long-term Plot Twisters project is kind of what we're getting at here. Like, I think Jenny would like to see. Right now, it's currently like a game world, like an imaginary game world, and it could be turning into like a sort of a physical. It's not imperative that they turn it into like a physical map, like a board game or whatever. But having a digital environment that either in a totally virtual sense or an augmented reality sense lends to some of the mechanics of the Plot Twisters stuff, which is kind of a bunch of. I won't even get into it. I'm not going to try to do it justice right now, but I think that's sort of one future thing to keep in mind for that. And then secondly, was basically the Wii Robot thing I just mentioned, but kind of I think, and this feels like everything I ever do. Like I feel like I always propose the same kind of projects, but having a sense of yes, I'll say frontier map, having a sense of like what's going on in the VR sense, like for what I said about tailoring to specific needs and also creating new opportunities. And I think there's something that is beyond or outside of Plot Twisters and maybe beyond some of the things we talked about yet so far, but that little discussion about like towards developing new ways of interpreting, like almost like developing a new sense organ, but how that what does that look like, and what can we interpret in that sense? And I think that like that's way deep into the new technologies, new ideas, new discoveries, like that 3-part thing, but like way. If you recall my question on Diva Worm, which I think you answered eventually, and I don't think I saw the answer, but the question was basically how do we? Well, it was like the formation of senses, I think, right?
Right.
Like, do you remember that?
Yeah, I do, and yeah, my answer was more like sort of evolution of sensory organs as they have been. But I actually, now that you mention this conversation, I'm thinking, the formation of them in terms of like if we could create them kind of not necessarily from scratch, like with technology, but in an evolving agent. Like, what would we have if we could have like a agent that would evolve just kind of like sense organs as like I guess you'd have to provide some baseline or some cues for this, but like what would be what would they look like?
Yeah,
Yeah,
and like I don't know how to formulate this particular thing, but there's an element of like some of the things when I think about sense organs, particularly in an evolutionary sense, I think back to my current fixation on analog and digital stuff. I think sense organs are directly related to certain physical stimuli that are interpretable, and um, there's there's reasons why whether it's time perception or heat or what like we don't, or sense of smell, like we have very particular gates, and this goes back to kind of some Adam Saffron stuff, and some like there's a pre there's bottlenecks and limitations, like the knee only extends to this many angles, so you don't have to think about how long to extend your knee, like that kind of limiter on the inputs. But given all that in mind, I think sort of the interesting stuff is like what where is there space for that's been the case, right? What does it have to be the case? Is there a way to develop other, I don't even know if they're really sense organs, but sort of like sense organs that maybe aren't directly tied to physical, like physics, natural environment stuff. And what does that look like? And is that does some sort of cognitive sense organ? I don't know. I don't really know. I don't know entirely where I'm going with that.
yeah,
But I'm a little bit inspired by things I saw at Princeton Vision a while ago, where there were people who were like, I think it was Nick Harbour or something like that, Nick Harbison, who he was experimenting with, literally creating like sort of different organs to interpret things physically differently, or like someone else, a French person, the next year they did like a concert where they were being able to sense and interpret like galactic cosmic rays, or like certain types of radiation based on how it hit,
right.
and they were like bouncing off of that. So it's like, I don't really know what to specify, but like it's sort of what is the developmental looking at what has happened is great. Like, how do the sensory organs evolve, and how they can like I kind of, I don't know if this is true, and I offer your critique of this, but like I feel like sense organs developed um, because there was important feedback that needed to get in a general sense, and then like there was a gigantic amount of refinement over the last like I have to imagine their emergence was sort of like do you know, like, was it more like a slow development or like a large development, and then okay, we have these organs, and then it's like meticulous refinement over time? Like, I know there's a billion different examples of that,
Yeah.
so it's not like one thing, but yeah.
Well, I think the general rule you can take away from like the tree of life, which is a massive number of examples, but that you have, you do have refinement in terms of like fidelity, and you have sort of specialization in terms of like a sense organ is specialized to detect different, say, frequencies of light. It could be specialized for, or for speed of sampling. So some insect eyes are really fast samplers of the environment. Um, and then that's happened a lot in different clades or groups of species in the tree of life, and it's you can't really say that there's any progression there. It's just that in certain lineages you get different specializations. Now I'm going to share my screen. I'm going to do a board again. Let's see. So I'm going to talk about this a little bit. This is a little bit different than what I talked about in the diva worm talk. So basically what you started out with are, sensory, I guess sensory neurons. They might be like this, and they might have a process down into some other part of the nervous system, and they may branch off to other processing organs, and then a downstream pathway here. So it forms a circuit. In C. elegans, you have different types. For example, you have different types of sense organs. You have like a chemosensation. You have, vibrosensation, which is sensing vibrations in the environment. And so you have all these different things, and you can have, like different, very simple photoreceptors. So the input comes into these cells. Okay, let's say this is one type, this is another type, and there's sensory input coming in from the environment. So there's an imperative for the organism to know what's going on in its environment. Okay, and so all these, this is going to be like an integrator where it's kind of integrating signal. Actually, I'll take that out. So that, these things get integrated very simply, and they get captured very simply. And you're basically, and these cells then maybe tune themselves to different types of stimuli in the environment through evolution or through development and evolution. And they become maybe specialized for certain types of stimuli in the environment. They might become very general, so they might detect a wide range of things. Their sampling speed might increase over time. Their sampling speed might decrease over time, depending on how much information is needed in the environment or from the environment. So there are all sorts of things going on it needs to bring into the nervous system. Now, these cells, of course, inside, they're not just like these magic boxes. They actually have ion channels on the outside. Those ion channel on the membrane. Those ion channels produce like different responses within the cell. So, when there's a certain type of environmental stimulus transduced, it triggers a cascade related to this ion channel, and it produces an output. It could be like a neuronal cell where there's an output, or more interestingly, you have single cell organisms where they're exposed to different things in the environment, and there are different processes within the cell that activate different responses. So again, they use this ion channel gating to sort of produce an output or produce some sort of process going on in the cell, and then it produces an output. It could be a behavioral output, or it could be an output to this network. So that's one set of things that are going on there. So it could be, I'm really kind of focusing on very simple single cell organisms or very simple circuits in the nervous system. Now, you're talking too about like in VR or maybe some other examples. So in VR and in some of these other sort of allied areas, people have experimented with sensory substitution. So I don't know if you remember this from, I think we mentioned this in the talk that we gave at SIGCHI last year. I think it was early last year. Actually, 1 year ago this month, where we talked about allostasis machines, and we talked about internal regulation, and we talked about sensory substitution as a way for, you can have like an extra sense, bringing things into the nervous system, essentially. So what you can do is you can have, you can substitute vision with some sort of other sense. You can blindfold someone, you can get a wand, and they can explore their environment. And that wand is connected to some array of electrodes that are put, against someone's chest, so that they're activated, when there are different things in the spatial environment. So basically, you're taking the visual environment, you're taking away vision, and then you're adding in this sense of touch, but it's indirect because the sense of touch is touching things in the environment, getting a spatial representation on your chest, which then has a spatial representation in the nervous system, but it's in the sensory motor cortex, not in the visual cortex. So in the human brain, which is, I'm going to draw a cortex here. All right, so this is basically a human brain here. The sensory motor cortex is here, and there in the sensory motor cortex, you have different types of cells, and one of the things you have is a representation of the body. Sometimes they call it the homunculus, but it's basically a representation of all the sort of the proprioceptors and pain, different types of receptors you have in your body. So, your hands and your mouth and your head, your face have more sensory receptors per square centimeter than does your chest or your legs or whatever. There's a famous little gremlin, looks like a gremlin. It's the homunculus. It's the human body scaled to the proportion of sensory receptors you have. Now, you're usually using your visual cortex, which is back here, to process visual information. But if you take away sight, right, then you can't use this anymore. So you're using your sensory motor cortex, in this case, specifically the homunculus, to process the spatial information. And there are connections to the parietal lobe, which then processes spatial information as a more general thing, spatial map that goes down to the cerebellum, and there are other ways, and the hippocampus. So there's a whole pathway here of things that are involved in this. So that's what's going on in the brain. You have this sensory substitution that goes on, and you can do this. If you look at, there are these studies that have been done in the past where they look at people who went blind or who are congenitally blind, which means they never develop sight, versus people who go blind early in life. And they actually look at how they use their different sensory cortices. So, for example, if you go blind early in life, you develop a visual cortex, and you have inputs coming in from your eyes, and then they get terminated when you go blind. So you no longer use your visual cortex. That visual cortex then degenerates. It's not used, and it's used for other things. There are inputs from the thalamus coming into this visual cortex, but the thalamus takes a bunch of inputs from different sensory modalities and distributes them to different parts of the brain. What will happen is that the visual cortex will degenerate for the visual inputs and be replaced by inputs from other senses. So like audition, for example, from the ears. Information from the ears will then get mapped to the visual cortex, and you'll not only have someone with enhanced hearing, but they'll have these sort of cross-modal relationships where they have to think about different modes of, they think maybe a little bit differently about how things are structured in the world. They'll use their touch, for example, in a very refined way that kind of replaces vision. This is, again, what we're doing with the sensory substitution. If you're congenitally blind, you don't develop any inputs into the visual cortex at all, really. And so what exists there is random, and it degenerates, and you get things from the thalamus from all of the other senses. So you're basically recruiting this entire visual cortex for the other senses. So that means that your other senses are now really being represented in the brain at a greater rate, I guess. So this is the way this works. And so you can have different senses, you can substitute senses, and you could create technologically a new sense. You could create like some sort of effector into the world, like a wand or something, and it would be like basically an end effector. It's functionally very similar to like a limb or a finger or whatever. And then that end effector will go into some sort of input into the body. So it could be like a sensory organ. It could even be an existing sensory organ. Like it could be, an eye, or it could be an ear, or it could be, I'm just trying to be like very general here. I'm not trying to suggest any one relationship. Or it could be touch. It could be anywhere in the body where you want to input this information. And then you're bringing it into the brain, and the brain has to represent it. Of course, we know representations are key for the sensory information to get processed, although there is a direct sensation. We won't get into that debate. But of course, the representation of this is important, and integrating it with some of the representations that we have already, because that's basically what you're doing. You're trying to integrate it into this existing set of representations and cortical fields that process information. So, there are these multisensory areas, which are, I guess, also in the parietal lobe and some other places. And they take in information from multiple sensory cortices, and they're integrating this information. They're special neurons that integrate the information both additively and multiplicatively. So they augment sometimes what's going on in the world. If you have like a congruent auditory and visual cue, those will be augmented somehow. So this is all something you have to think about. If you have this like alternate sense organ or this alternate sensory modality, you can create this using technology, bring it into the brain somehow, maybe through some allied channel. Like, for example, a wand will be brought into the body through touch indirectly, but it's like coming in through that channel. And then that channel, it gets converted into some representation in the brain. So if you're using some sort of alternate sense organ, you might have something that, like if you have a blind person, you might create an organ or like a sensory device that plugs into this visual field and recruits it for that new sense. Or it could be something that is brought in through the proprioceptive pathway. And it's going to be limited to what that proprioceptive pathway can process. But it's maybe fundamentally different because this wand has a much better spatial resolution, say, than your body's proprioception. So your body's proprioception usually doesn't have very high spatial acuity. It just touches things and things touch you, and you kind of know where it is, but it's not like a spatial map. But in this case, you may need a spatial map. So you can plug into this system and, there's maybe some spatial representation that gets formed over time after you learn how to use it. So these are all things like, there are these two components. There are the very simple sensory organs, which bring information into the body and the way they behave, the way they sort of work, the physiology, and then they're kind of hooking into these networks. And then I kind of scaled up to human brains. I talk about sensory substitution, which is where we're kind of, working with our different sensory modalities, plugging in new devices maybe that mimic these organs in some way. These devices actually might be better designed if they kind of mimic the kind of way that we have very simple sensory organs or sensory cells that take in information and process it. So, there are a lot of ways this can be done, but this is my sort of my cognitive science answer to your question, whereas in Devoworm I gave you more of a evolutionary biology answer. But that's basically it. That's how I think about it.
No, that was awesome. I'm gonna go back and look at all that. So I think that would be kind of a little is to follow, as we say.
Yeah. So yeah, I mean, yeah, it's like, so yeah, that's a something that people have done a lot of. They've done some work on it. It's not been. It's an underserved area. Like, it's not been studied enough that it's oversaturated. There have been people who've done experiment. Like, it's like one of these fields where they do an interesting experiment, and they're like a collection of these interesting experiments across different areas, and people have talked about it for years in terms of isolated experiments. People then have maybe tried to make a theory out of it, but it's like, it's not really kept up with like the neuroscience. So it's not really a neuroscience argument when in fact you do need to have some neuroscience on it, sort of to understand why, how this would work, why it's important. Um, but I like the stuff that we were talking about. Like Adam Safran has talked a lot about the role of the body in this too. That you have things like the knee or like the different limbs and their physiological limits. So they have a range of motion. They have like these proprioceptors that have a range of a dynamic range of sensation, and you're kind of limited to that as well. And then, of course, an artificial sensory organ or an artificial sensory cell would have these same limitations, or maybe they'd be different. And if you plugged in, say, like an artificial proprioceptor or an array of them, and they had a higher dynamic range than your proprioceptors that you have natively, say you were creating like an artificial limb, and you plugged it into the nervous system, what would that be like for your brain? Would your brain know how to process that information, or would it just be like, be able to pick up on the patterns and the cues? And so there's a lot of stuff to think about there.
Yeah, definitely.
Okay. Do you have any other questions, Samantha? I don't know if you had anything to add or anything you wanted to.
Sorry, no real questions. I thought it was all really interesting. I had a point for what you were talking about earlier. I just didn't want to cut you off with the virtual reality.
Yeah.
And reaching out to new Albany interns. I don't know if you're aware, but we added a program in game design that is used in the College of EHC that most people are thinking of using it for like virtual reality and simulations. I don't know how far into virtual reality we've gotten into because it's not the program I specialize in, but I know, Jesse, I think you're still in contact with like Dean Goodall and Mike Baumgartner. You reach out and ask them about that because the game design program grew a lot in the last semester. So for like virtual reality and augmented reality, I feel like that's where you can get interns from.
Yeah.
For that stuff.
Do you know if, who's the guy? Who's like I know there's like Berg and Goodall and Baumgartner. Mm-hmm. Who's the guy who's like he's like a younger guy who's really into all that stuff. Do you know the name of him? I can he's easy to find.
Yes. I feel like I do a lot of the open houses, and the only people I see talk is I think someone, I forget his last name. It's like Norman, something with a G, I think. I don't know if he's data analytics or game design, but he's involved. Oh, Mike Lazinski.
Yeah, that's what I was thinking of. he's done so much for that stuff, and I haven't been following it that closely, but I saw some like social media posts about how much the esports and some of the game design stuff is taking off. So that's great to see. And I think that's a good. And that was in the back of my mind, I think, but I appreciate you definitely like saying that explicitly because that would be a very good connection to what I'm saying. So thank you.
He also does like drone labs and things like that too. If you had like drone questions, I feel like he'd be the person.
Is there still like there was a whole big thing. I was there when the drone lab robot arena opened up, like in the old basketball court. Is that still a thing there? I don't know.
Yes. Yeah, that's still in the downtown campus, and then they moved. I don't know if you've been in the new
No.
tech building, but they moved like the makerspace and everything
Okay.
there.
Yeah. That's cool. I gotta see the new building. I've yet to. Each time I've been in Albany, it hasn't worked out. But I'm doing there, so I'm glad to hear that that's doing well, because there was a lot of I went through this period of like such transition between like the nano college dropping out and informatics changing from science or arts to out of the engineering school into the EEC, and it was such like a, we're doing this now, we have this now, but we'll take it this new building, and so I'm glad it's coming along. So that's good to hear.
Yeah, that sounds great. Thanks for that update, Samantha, and the contact information. It makes sense to reach out in terms of specific things we want to do. I think it's, it's a good way to kind of find, I mean, this year I think I don't know if we recruited interns from specific areas, but it was, kind of like, do you want to do this? If we're looking specifically for like a VR person, that might be, and I mean, people at that stage of their career, maybe they don't, know so much about that, but if you have the background,
I think the way I found out about this, it was sent to me from Kersey, but sometimes if you send things directly to like BHC or like the college whoever's in charge, then they'll send it to the people on their list of people who are interested in that specific position or job or something like that.
Yeah, Kersey is that for Bradley. It looks like curse with CURC.
Yeah.
And that's with Casey, who worked with us before. She's great. But yeah, I think I have one. We could definitely get something sent out to them for sure, both the departments and also the QC guys. So I think we're determined to do that.
Yeah, that's great. Thank you. Okay, so I wanted to talk a little bit about, we were going to talk about this thing. Oh, hi, Erin. How are you?
Good, thank you.
Good. So I had a couple other things to talk about. We had that discussion piece by Jan LeCun, and I believe there was something else, but I can't remember now. Oh, yeah, I wanted to talk about the new Discord. So why don't I talk about that first? So I've talked, was that?
I was saying, I wanted to hear about
that. Yeah. So this is the new Discord, and it's just kind of in its early stages. Danielle has joined. So she's going to be creating channels here. So this is called the Education and Big Unfinished Ideas Discord. It's largely for education. So people are, this is something where we can bring people in and maybe do organized short courses or things like that. And so Danielle is interested in doing things with the slow pod of NeuroMatch, and then maybe adding into that experience with other things, like tying in like active inference lab materials and kind of, giving people sort of a deeper understanding of those things. So, right now, if you take NeuroMatch, you run through it in 3 weeks, and, whatever you pick up, you pick up. If you don't, then you have to leave it on the floor and you, you race to the finish line. With the slow pod, you can work through them more slowly, and you can do this just by watching the videos, or you can, kind of work through them and then say, well, what does this have to do with anything? And then find other resources. So it's basically a lot of curation. There's also some instruction, maybe some assignments or things like that we can work out. And this is something we're going to work on. It's a long-term thing. I don't know when we're actually going to have our first cohort or how we're going to do this. I'm also thinking of doing a biocomplexity course that I've had sort of in my back pocket for a long time. I've worked this out. It's a curriculum for kind of going through biological complexity, but for people who, maybe don't have the background in biology, or, usually it's for people with a computational background, but it could be people who don't really have expertise in either and want to gain expertise in both computational stuff and biological stuff. So there's a curriculum that I've kind of worked out, and I have the lecture notes for this, and some of the demos and the homeworks and things like that. But that's something that I'm going to work on as well in this channel, in this space. So this space would be for like teaching, for education, very specifically. And I mean, I would think the way it would be run would be like people would join the Discord. They'd kind of get there'd be different channels, maybe a general channel for that course, and then some discussion channels underneath it. And then, that would be a way to facilitate involvement. Discord allows you to have audio channels, apparently, so you can have like audio recordings. There are other, you can link video recordings in, of course, and there'd be, we have to figure out the structure of this, but basically it would be run off of this Discord server, and, that would be a way to maybe facilitate, it wouldn't be in our Slack, because I think our Slack is busy as it is. We need a new space for that.
Honestly, I would love it if there was more. I would love the Slack. Excuse me. I would love it if the Slack was predominantly project focused, and I know it won't be. But like, it would be great to have like. It won't work out. It won't work the way that I want it to. I would love it if the Slack was a bit more like project specific updates or really tailored things to those projects. I'm trying to make channels that are more focused specifically on projects as opposed to like big concepts.
Yeah.
And I don't think that will really happen. I don't think we can magically transform all of our news content and article updates to Discord. But
yeah,
I think that's me sort of being petty, I guess.
Well, I think the way to do that is to like have a organized have an organized update. Like, how we have the bots for updates, and they're very simple. It's just like it asks a couple questions, but to have like almost like a stand up or like an update where, I don't want to say it's like a newsletter, but sometimes the newsletters work better, because it's like if you have everything in front of someone, it's like, this is what's going on. And then like people are, oh, okay, that's an update. And then, they'll add to it. It's like if you just expect people to go in and say, I'm going to give an update every week. Again, it's like what I was saying with the papers, that if you just leave it to people and say, this is what you're responsible for, and then the next week you ask people, what do you have? They won't necessarily have anything, because it's, they don't, that's not the first thing on their mind. So sometimes it's better just to synthesize, have discussions, synthesize them, report out to the group. And then from that report, people can follow up and say, oh yeah, that's what I was thinking, and I have more to add. And I mean, it's just, I've tried to work on this for years, how to facilitate this sort of stuff. And this is what I've come up with, I think. It's, But yeah, I think Aaron liked the idea of the Discord, so thank you.
I wanted to ask, with the big ideas versus the rundown of events and keeping track of things, I'm not sure if this is what you want, but I don't like it when people can't get what they want, if it's a good thing. So
yeah.
I wanted to just offer, you can label different threads or something, or I don't know how you want to do it, but I'd say go for it.
Yeah.
Positives, and let's push it through. Label things. Tell me where to put the big ideas and where to put the agenda stuff, I guess.
Yeah. Yeah, I think it's it's always a challenge to get things organized, and I'm not sure how they do labels in in Slack. I know that in, like, if you use what they call Discourse, I don't know how many people have used Discourse. It's where you set up a server and it's like, they have labels for things, and that's kind of the way it runs. Slack is a little less functional in that way, but I wonder if there's a way to replicate that, because you can have a channel, and then the channel has, you can make a lot of channels. Yeah.
Discord has more permissions for channels. Like, you can have a little bit more. Maybe not that much more than Slack, but you can have a lot of customization. It's just Discord doesn't. Discord, the biggest thing that I think operationally separates the two is like the dedicated voice channels, yes, but also Slack has common threading, and I don't like. There's less. Discord is a bit more chat based. I find it harder to find what I want to find in Discord sometimes. So they're both fine tools for different things. But I do think having having the Slack is a good idea. I know the Discord is a good idea. I think we had a Discord a long time ago, but it was just for critical periods, right?
Well, we do have the critical periods Discord, but that's something that hasn't been as active as I would have liked it to be. But it's just you can make a Discord for anything. This is a little bit different than that, because this is like kind of a different sort of focus. You have
Yeah, I like that. There's this. I think having a space that's more amenable to rambling and unsorted ideas.
Yeah.
Let's say. So yeah.
I kind of made the big unfinished ideas things as kind of like a, that I don't know if we'll keep that like heading, but like, well, we might actually do that as well. Like, when I think that, I think like, can we have like a course on things that aren't really fully formed yet? Like a participatory thing where we say, well, we're interested in VR. We have this idea that isn't, maybe it's not like something you can have a course on, like where you have assignments and things, but, maybe it's something where we kind of participate like we do with cognition futures, and then kind of fashion different lessons out of it. Almost like you're participating in designing it. From like just stuff that you've been talking about. So we talk about things in our channels. Can we design like, a more formal experience, or almost like you're designing a field of study or like a formal course from these discussions, and kind of just, pushing it into something a little bit more concrete. Oh, you're going to say something, Jesse?
No, I'm just coughing.
Okay. All right. So that's great. That's the what's going on in the education sphere. I just wanted to give an update. Next, I wanted to talk about this thing that Jan LeCun put on Facebook, that Jesse posted on in the Slack. So there's all this debate, there are all these debates about like AI and, breaking through walls and all this. It's just too much sometimes. It's, Gary Marcus and Jan LeCun usually are at each other's throats about this. But, so, and this is good though. This is, good to have like these debates, because sometimes you get a lot of interesting sort of grist out of it, and sometimes not, but you have to have the debate to get there, right? So this is talking about this raging debate regarding the significance of recent progress in AI. So it's like, are we achieving general intelligence, or what are we achieving? So Jan LeCun said it's maybe useful to restate a few obvious facts. Number 0, I know he likes to number from 0 because he's a computer scientist. There's no such thing as AGI. Okay, so that's artificial general intelligence. Reaching human level AI may be a useful goal, but even humans are specialized. I think that's, I think we've talked about that. Like last week we talked about the evolutionary neuroscience and systems neuroscience from an evolutionary standpoint. One of the lessons there is that humans aren't really at the pinnacle of intelligence. I mean, we're a very intelligent species, but intelligence evolves in different ways and it gets specialized in different species. And we're specialized for our sort of the lives that primates lead, So, there are different things that we have, some different sensory organs. There are other, species that are also very intelligent, and they have different ways of expressing that intelligence. So it's something to think about when you think about this. You were going to say something, Jesse?
I was chuckling at some things, but your presentation seems to be fading in and out, Bradley, and I'm not sure why that is.
You mean like the audio or the
screen sharing?
Oh.
I'm looking in Gisty, and it seems to say that your connection is lost or not. Like it's not that the screen is going away. It's just that it literally fades in and out from just showing your BA avatar.
Oh, yeah. Sometimes if the connection is not very good, it does that.
Yeah. But we can go on with the.
All right. Yeah. Yeah. Sorry. So that's point 0. Point 1 is that the research community is making some progress in this direction towards human level AI. So, we can mimic human level AI or making some progress towards it. There's this whole debate about scaling, which I don't want to ever get into, but scaling up helps. It is necessary but not sufficient, which means that it needs to happen. You need to be able to scale up from like smaller. I guess scaling is like scaling from simple to complex, or in terms of size. It's not sufficient though, because you need other things, but it is necessary to have this ability to scale up. So point 3 is we are still missing some fundamental concepts. So we don't know certain things about how to get from like what we have today, which is good pattern recognition, to something that mimics human intelligence. Some of these new concepts are possibly around the corner. So like self-supervised learning, where you're not having to train the model on labels. That's something that would be helpful in reaching human level AI. And again, this is again like how we've sort of abstracted this problem, right? You have human level AI, you think we know how humans think. I mean, we're humans, we observe how other humans think. But it's, how do you sort of turn that into something that you can compute? And so that's another thing that, I don't know if he really mentions that, but the abstractions are actually important too. And then 6 is we don't really know how long it's going to take to reach this goal of human level artificial intelligence. So I think, that's an interesting point, that we don't want to put a timeline on it. There are some people who are very optimistic about our timeline. They think like maybe in 10 to 20 years we'll get there, but that's probably unrealistic. So he says, I really don't think it's a matter of scaling things up. There's this whole debate about scaling things in AI, and that's the way to achieve general AI. That's probably not true. It just means scaling just means like making it bigger or making it more complex. And, that's as opposed to having fundamentally different concepts driving these applications. So instead of just having better pattern recognition or more pattern recognition, we need other things in there. And I think, that's a lesson even we learn from AI ethics, but also a lesson we learn from some of the biologically inspired stuff, is that there's this need to have, a diverse set of concepts in the mix. If we want to achieve something that not even just resembles humans, but resembles some, organism that has a pretty complex nervous system, like, Drosophila or fruit flies. You need to have this framework. So you're going to say something, Jesse?
Not just that, I know I say it all the time, but just reiterating how much there is basically dogma and partisanship about it. Like there are people who are hardcore committed that if you are, all we need is scaling, all we need is more. I mean, it's maybe not fair to say, like, always, like, the deep learning will save us, hashtag or trope about that. But I actually just made a note also, like, in my own frontier map thing, is that when for the template that I'm building out for, it's interesting to think specifically about the debates like that. Like I may try to make I don't know if formula is the right word, but something within Obsidian that could easily track. Like if you're gonna make, like, if you're researching, for example, Jan LeCun, this post we're looking at is a great sort of indication of where he stands about a lot of things. And so being able to sort of tag, okay, like Jan LeCun, has reservations about AGI because of X, Y, Z. Yes, he disagrees with Market about this or that, but like this is his opinion about the scaling debate.
That'd be cool, like a notepad of philosophical sort of positions on it. I like that.
Yeah, and being able to, like, part of what the trick with the frontier map stuff is, like, and implementing it in Obsidian, which is sort of the note-taking app, is like, how is there a way I could basically create some very simple templates that would carry over well, so like you could just easily fill that in, and then maybe collect, like, you could sort some of the information, like, okay, well, here's a
Like link to it
on, like, in terms of the debate about scaling, here's what all the views are that we know and that I know, which is a bit involved, but also I think it's not that hard to do in Obsidian. So more about that later. But yeah, the partisanship aspect is interesting.
Yeah.
So.
Yeah, I think with a lot of these debates, that's what you get. You get a lot of the partisanship, I guess, and not a lot of more smoke than light, so, or a lot more heat than light, I guess. So he also mentions we still don't have a learning paradigm that allows machines to learn how the world works, like humans and non-human babies do. So this is, again, the developmental aspect. How do you get something from nothing? Some people think of this in terms of emergence. Some people think of this in terms of, like, development, and maybe a mix of the two. There's definitely, sometimes you need maybe a innate component put into the algorithm, but you obviously need to build on that innate component, because the innate component isn't enough, because that just gives you a baseline and it's fixed. It's not, like, adaptive. So, so we don't know how that. I mean, we don't even really know how that fits together in humans or other animals, much less in AI. I mean, we kind of do, but it's, so some may believe that scaling up a giant transformer trained on sequences of tokenized inputs is enough. Others believe reward is enough. A few others believe that explicit symbol manipulation is necessary. A few don't believe gradient-based learning is part of the solution. So these are all, like, different solutions that different schools of thought that, it's like, my school of thought is the best, and we have to be pluralistic in that sense. So we need to find ways to learn how the world works by observing, like babies, predicting how one can influence the world through taking actions, learn hierarchical representations that allows long-term prediction in abstract representation spaces, which is basically where you have these spaces, you have a representation that's a map of the world. how do you work from that and then build, because this is something you need for generalization. You need to be able to build a map of the world through, you don't observe the entire world all the time. You build a map of that, and then you have to operate from that map, or the AI does, to make predictions in real time. So that's how our brains kind of work in a way. We have these representations of the world, these mental models, and then we operate from the mental model. We don't necessarily operate directly from the environment or directly from our sensory world, because it doesn't have a lot of context, it doesn't have history, it doesn't have all the things that we need to really kind of put things together. So this is something that we don't know. And this point about observing like babies, that's development, but people have been talking about this for years. And there's an area of developmental robotics that's actually been working on this for years, and it's not really clear that they've gotten very far. The question is like, do we really? Maybe we don't. Maybe mimicking development is maybe not enough, even within that category. Like, we talk about development, and what lessons do we learn from development? Is it just taking this idea of learning like a baby, or is it something deeper? Like, there's this process of acquisition of information, and there's this interplay between like an innate representation and a learned representation, and there's a certain way that works. So we don't know how to even implement the developmental question that we want to answer, I think, is my point here. But I think saying observing like babies is a little bit like saying, we have brains, and how do we mimic those? It's just not really that descriptive. So, but there are a lot of things in here that I think, if you are a big fan of embodied intelligence, is good news, because you're on the right track probably. And so I'm going to leave it at that. And I think, yeah. So yeah, Jesse put a thumbs up, and Aaron said, we adapted because of pressures on human bodies. So do we even want to have algorithms which mirror our own? And that's a good point. Like I said, the bio-inspired approach is interesting because it puts this in a context of like adaptation and specific environments that we evolved in. So, if you have an AI, do you want it to mimic humans? Do you want it to mimic fruit flies? Or do you want it to sort of evolve in its own world of adaptive pressures and things like that? Maybe it doesn't resemble anything living, but it's living in its own way. It's an interesting point. Jesse said, Jan also posted some kind of formula for calculating how many frames of information children see compared to machine learning. It was meant with some interesting contention. I may have also put that in the to discuss thread. So let's see. To discuss is this channel here. We have, this might be it here. By the time a human child turns 5, she has seen the equivalent of 800 million frames of video, audio, touch to learn how the world works through self-supervised learning. Much of it is acquired actively. I mean, you can make that estimate. Sure, I don't have a problem with that. It's important to understand, we're sampling the environment continually. And, the estimate's the number isn't really important. The point is that there's a lot of data involved in, say, learning through development or through experience. If you get to if you have a 5-year-old algorithm that's learning things like this, that's a lot of data.
I have a question about this.
Yeah.
Particularly about the data and the modeling stuff. Like, is there a specific? I think what separates this, and there was some interesting in the comments to that discussion. There was like some discussion about, is it active or not? Is it like how do you not so much the numbers, but like some conceptual challenges to it. And I don't know how to really articulate them right now. But my question was mostly like, when one is interpreting like I think a major difference between what I kind of know a bit about what Jan's doing at Meta, Facebook, whatever, in terms of the self-supervised stuff, trying to get video from a first-person perspective, and going from there. I think that's a great thing to do. But I feel like a missing link is even as a child who is clueless, and this is part of the magic of development, I suppose. Like as a child, you're not. I certainly, at least I'll put my hand there and say, I was thought intentionally, consciously modeling or using my attention to discern many different aspects of the world all the time. I wasn't intensely focusing on the physics of my legs. I wasn't intensely focusing on that. The day-night cycle is the same. I wasn't intensely focusing on that. My parents are relatively stable personality and use a stable language, and like the rules aren't changing all the time. And I guess what I'm getting at is like, how do you account for I would almost say latent, or the things that are not consciously focused on in the modeling process? Because as a kid, like, as a child or whatever, even as an adult, whatever, like, I'm not just getting frames of understanding. And I don't know if this has to do with the active versus passive or whatever, but I'm not just like, I am literally constantly checking with my model of what physics is and how my body is, my proprioception is. I'm constantly representing that thing. I'm not always consciously doing it, but I feel like I'm always getting more data and reference points about it, nonstop, continuously, and I feel like that's totally not. I don't know anything right now that I feel like we can have these sort of like machine learning periscopes that let us look very specifically at some things, but even in a generative sense, I don't really know. Like, how do you talk about that? Because I feel like there's a huge disparity there.
Yeah, I mean, this is kind of one of these things where you assume that, like, like what we do in machine learning is we train a model, we take some data, we throw it in, and we see. And then the idea here, I think, implicitly is that we're scaling up. So how much data do we need to mimic development? Well, we just need to scale up our training data. Now, the problem with that is that that's still not going to help you, because you have these representations that you use. You have what they call naive models of physics. So when you're a child, you have these naive models that you kind of know that, like, for example, where when you're an infant, you learn that things, if you drop them, they fall. And then you learn that. And then eventually you're going to learn more complex physics. But you have these representations that change. So, these are things, and you're checking constantly with these representations. You also have autonomic processes like circadian rhythms that sort of underpin your cognition. And those things are, you don't necessarily check those. Those are autonomic, and those kind of influence you in different ways, but they're not things that you can you can train into a model or interact with. You can, entrain them, meaning you can synchronize with them, but they're kind of on the side. They're not really something that data makes a difference with necessarily. So that's the thing. You have training data, and you can have a lot of training data, but you still don't have things like representations or these autonomic processes. Or this is why this idea of innateness is so intriguing, because you can model these autonomic processes using some sort of a set of innate processes, basically encode them, say maybe into a genetic algorithm or something, where you just make sure that they're stable over the course of development or training. And then you're putting in data, and you have this part of the model that learns and adapts. And then the innate model is there and it's kind of interacting with it, and then that's sort of mimicking how you, and then you also have representations, higher order representations, which also give you some, some guideposts. So all those things would have to be there, and so this estimate is interesting, but at the end of the day, that's just sort of scaling up instead of kind of enriching the representation or the enriching how the agent's world, how it's the sort of the architecture, and so that's
I think that's sort of the I'm looking for a certain almost like religious term about mystery, but the mystery of the embodiment question is kind of about this, like what is the amount of embodiment you need to have that stuff going on, because the giant disparity for me is just like biology is just literally millions, billions of years of ancestral legacy that has shaped everything, and like so much that it's always had to biology has always had to account for so much, and all the technology is to account for so little, and we don't even know how to account for it. And it's like, what is that? That's like the gap, or like the bottom up and the top down gap of like our vantage point, I guess. And we'll see. I feel like this would be a perfect conversation to have at the Embodied Intelligence Conference. Let's see what they say there.
Oh yeah, definitely.
I would love to almost like propose a discussion group for the Embodied Intelligence Conferences, like kind of like for the Coxside thing.
Yeah.
Just kind of like say, hey, we'd love to have a little extra time, or almost like a side, either discussion group or like a side workshop or something. I wonder if they would go. They might go for that.
Yeah, maybe, or a neuromatch even. We could. I mean, I don't know.
Too.
Yeah.
Yeah, let's think about that.
Yeah, definitely something to follow up on. My final word on this is like, you say, well, how do you capture evolution in biology? And the answer is you have to abstract these systems. You have to take like all the complexity of it and make an abstraction, which means you're picking features that you want to put in your model. And the question is what are the most important features and what are the most salient to what you want to do? So this is where we've gotten in trouble a bit in the past, is that we just say, well, we just want to have this network of neurons and connections, and then that's enough. And then, of course, that's probably not enough. So we need to have like some other support systems in the mix. But then we don't also want to take like everything that an organism does or has and put it into the box, because that's also that doesn't yield anything. So, it's that mix of finding the right things to represent in your model and to have them, work together. And that's, so, all of this metabrain stuff, I think, is actually quite going in that direction, because, we've been talking about it, different levels of representation, different features, different ways to interact between those levels of representation. I mean, I don't know the answer. I think that's probably a better direction than saying like, well, deep learning is going to just break through a wall and become AGI. So anyways, so that's good. That was a good discussion. And definitely we should maybe do like a discussion group on this somewhere. It would be good to have a lot of minds attached to this. But I'm going to go through reading before we go. So I think I'm going to do one more thing here from this folder. I wanted to point this out yesterday at our Google Summer Code meeting. I mentioned this Twitter conference presentation that we did, and I brought up the wrong slides. So this is the set of tweets so we had this Twitter conference 2 years ago where we did this, the idea was to do this in like 5 minutes, and you have to do it in like 6 tweets. and you have to kind of present your work as a presentation, but it's on Twitter. So there's this title slide. This was our developmental Bratenberg vehicles work. So all of our people here. And then, we had each slide kind of went into our work. We used developmental Bratenberg vehicles and kind of, you attach images. So this helps you to visualize what people are talking about. This is like a flash talk, but it's like an extreme flash talk because you have to get this into 240 characters in an image. And so just kind of walking through the broadgen brain algorithm, which is one version of a developmental vehicle. This one is another version of a developmental vehicle. This is a multisensory approach. Then this is the third approach, which is a collective behavior approach. And then finally, number 6 was kind of for more information. We had our paper at the time, we had it on ResearchGate, but now it's forthcoming in Artificial Life. So this is basically the way you do a Twitter conference. I wanted to bring that up because I misfired yesterday and didn't have the right slides up. But the other thing I wanted to talk about was this information of just noticeable information as just noticeable difference. And so there's this concept in psychophysics called the just noticeable difference. And it's like, if I present to you a stimulus and I want you to pick that stimulus out from a background of noise, I will present that stimulus at different intensities, and I'll present like a background of static. And you know what static sounds like. And the idea is you take like a tone and you present it at different volumes. And so the idea is that the person has to select whether or not they've detected that tone. And sometimes it's totally embedded in the noise, and sometimes it's very distinct from the noise. And so the question is how close to the noise threshold is your sensitivity to this stimulus? And so this is something that's very common in psychophysics, where they measure your sensitivity to something, and it's like the measure of auditory discrimination. They basically call it that. Now, I found a couple papers, and this is something we've explored in the context of Gibsonian information, which is this idea of information as just noticeable difference. So the idea of information being this ability to discriminate from noise. Now, we've talked about information theory in the past, and we've talked about it being a matter of diversity or a matter of different states and their prevalence in what they call an ensemble. In this case, information is different. It's how can you detect things from noise? So it's this detection aspect of it. And so these two papers kind of get into this idea. So this first paper is Magnitude Sensitivity, Rethinking Decision Making. This is a Trends in Cognitive Science paper from last year. The abstract reads, and I'll zoom in a little bit. Magnitude sensitivity refers to the result that performance and decision making across domains and organisms. So this isn't just in humans, this is in all organisms that are have the sensory system that we're sampling here, is affected by the total value of possible alternatives. So this is something actually, it is tied to what we call Shannon information, which is you have all these different states and an ensemble, but then there's a total value of this. So this is the magnitude sensitivity. So it is tied to the Shannon information, but it's distinct from it. So this simple result offers a window onto fundamental issues in decision making. So you can think about like decision making as taking into account different alternatives and evaluating them, assigning a value to them. But it's also tied to your availability of different alternatives in your current ensemble or your current world. And so this is, of course, linked to decision making. And has led to a reconsideration of ecological decision-making, prominent computational models of decision-making, and optimal decision-making. So there's this huge decision-making literature where they talk about these different types of decision-making. Moreover, magnitude sensitivity has inspired the design of new robotic systems that exploit natural solutions and apply optimal decision-making policies. In this article, we review the key theoretical and empirical results about magnitude sensitivity and highlight the importance that this phenomena has for the understanding of decision-making. Furthermore, we discuss open questions and ideas for future research. And I don't have the full paper. I downloaded this, and unfortunately it doesn't have the whole paper, but we can get this. We don't need to talk about it right now. I guess I can open it up. Okay, so this is the highlights here. Performance and decision-making is affected by the overall magnitude, i.e. summed values of the alternatives. So this is like conventional information theory. This result is known as magnitude sensitivity. So this is a little bit different than the magnitude sensitivity I mentioned before, the psychophysics version. But it's connected to it because you're looking at this magnitude sensitivity within this framework of information theory. Basically, you're looking at the different alternatives and you're determining which one has the greatest magnitude or which one is the most salient given the background of noise or whatever. Magnitude sensitivity is observed for all types of decision-making, perceptual, value-based, economic, and collective, and for different organisms. So they have a collection of model organisms here, from unicellular organisms to humans. Magnitude sensitivity allows organisms to optimize speed-value trade-offs for naturalistic decisions, which a fast choice for high-magnitude stimuli is often preferred over a slow but correct one. So in other words, if you see something that's high, that's very salient, that has a high magnitude above noise, you will select that. And that sometimes that's good and sometimes that's bad. You can make a slower decision, spend time discriminating between things that maybe are closer to the noise threshold, which might actually be the correct choice. So there's this trade-off between speed and value. And so this type of information allows organisms to optimize this trade-off, but also that there is this trade-off, and it is tied to information theory. Prominent accounts of theoretical, descriptive, and normative decision-making need to be revisited in order to account for magnitude sensitivity. So this is focusing on decision-making, but I would say you also need to go back to information theory and recast it a little bit in terms of making the distinction between like a typical Shannon information approach and this type of approach, which is closer to how we describe Gibsonian information. So we need to revisit that, I think. Finally, magnitude sensitivity has inspired the design of decentralized algorithms for robot swarms that efficiently manage the speed-value trade-off. So they've implemented this, or you can implement this in robotic swarms or groups of robots that are making decisions, sensing their environment, picking out the most salient things that are above this noise threshold, and then making decisions based on that. So that's this paper. And then the second paper is Information Theory and Vertebrate Stress Physiology. So this is a quite a bit different view of it, not cognitive science-based, but actually physiological-based. This is in trends in endocrinology and metabolism, so it's a different audience, different system, but it has some commonalities. So the highlights of this article is that information theory has been applied productively in many biological subdisciplines, but has only just begun to be applied in stress endocrinology. So they focus more here on information theory. Information theory has been critical to developing neuroscience as a key subdiscipline. Integrating information theory to stress biology will allow developing full, cohesive, quantitative models of stress focused on relationships amongst traits, trait categories, and trait-environment interactions. So this is looking at stress and looking at the sensory inputs to stress and looking at how those are processed in the system. So presently, the majority of models of stress center on the regulation of hormone concentrations, even though what interests most endocrinologists and matters in terms of individual health is the information content of hormones. In neuroscience, the free energy principle, they go back to the free energy principle, a concept offered to explain how the brain infers current and future states of the environment, can be a guide for resolving how information is instantiated in hormones, such as the glucocorticoids. So they offer several ideas and options in this paper for addressing this information processing of hormones and how that is explainable by the free energy principle. So they're kind of drawing from this free energy principle, and so they go back to Gregory Bateson, who had a famous phrase, differences that make a difference. So that was his definition of information. And that would be that magnitude sensitivity we talked about earlier, that these differences between signal and noise are the difference between information processing and non-information processing. So, this is something that they link to the free energy principle, and they talk about different biological levels. So you have in biological systems this vertical organization between cells, organisms, and the environment. And hormonal effects are notoriously complex, and they manifest and present over multiple timescales, sometimes over very long periods or even generations. So across biological levels, causal relationships are what they call hormetic, and that's something I'm not familiar with what that means, and vary temporally as well, with acute and chronic elevations having distinct outcomes. So you can see where we want to know something about how information processing happens in these systems. And so that's what they get into here. They kind of get into like a little bit about noise and structural errors. So they kind of draw from information theory to address some of the noise components of this physiological system. They get into some of the issues of how that affects information processing. And then, so this is a nice paper. I don't want to get too far into it because we're out of time. But they talk about semiotic and syntactic information and surprise, which is something that we talked about in Bayesian surprise, which is kind of another form of information. So this is interesting. They're talking about these concepts in the context of endocrinology. And again, like with a lot of these, like with Michael Levin's work on cell agency, this information, it's all pretty much sort of a metaphor. I mean, you can map it to specific measurements, but you have to understand that there's these things exist in a specific context. So when you say semiotic information, it's going to be something different in human language than it is in endocrinology. So just to keep that in mind. But this is a really interesting paper, and it kind of gets really deeply into these issues. And so, I think that's a nice summary of some of that work, and maybe we can follow up on it later. Thank you, Samantha, for attending. Okay, so I guess we're done for this week. Do we have any final comments? Okay. Well, have a good week. Catch up in Slack and online, and have a good week. Have a good Memorial Day weekend.
Oh, I forgot it was Memorial Day.
Yeah.
Bye.
Okay. Bye.